Okay, section 2 is about ratios and proportions. It's basically preparation for doing some of the problems that we're going to do in the next couple sections with similarity. So let's talk about ratios and proportions. First of all, what's the difference? Okay, is it the same thing? Are ratios and proportions the same? Ratios are basically fractions. Okay, so a ratio is like 3 to 2. It can be written like this. You can also write it like this: 3/2. That would be a ratio. Proportion is basically an equation. So it's an equation made up of ratios. So when we're looking at proportions, it would be something like 3/2 equals x over 5. That would be a proportion. Okay, and we can solve proportions using some of the theorems that are down below. So the first one I want to talk about is this one right here, the means extremes product theorem, or MEPT, which we'll need later on in the chapter when we're doing some proofs. Okay, so means extremes product theorem is basically if A over B is equal to C over D, then A times D is equal to B times C. We also know this as cross multiplying, which we did a little bit of in the first section, cross multiplying. Okay, and so like something like this problem up here would just be 15 over, equals 2x, so x is equal to 15/2. That would be solving an equation using the means extremes product theorem. The means extremes ratio theorem is basically the inverse of that. So if PQ equals RS, then P is to R as S is to Q. And the way I did that was I just thought about, okay, if I cross multiply, will I get what I started with here? Okay, so you can kind of work backwards into that. That also means that there's other proportions you could have written. For example, I could have flipped the Q and the P here, and I could have written Q is to R as S is to P, for example. Okay, and there's other ones also that you can write just like that. Okay, so let's talk about something called the geometric mean, or the mean proportional. These are the same. Okay, so a geometric mean is basically when you have a proportion, so like 1/4 equals 4 over 16, where these in this position in the proportion are identical. They're the same. So in this case, 4 is the geometric mean between 1 and 16. So if I wanted to find the geometric mean between 3 and 27, I would set it up like this. I would say 3 is to x, that's the geometric mean we're looking for, is equal to x over 27, and then I would solve for x. So x squared equals 81, x is equal to plus or minus 9. Keep in mind that when we square root both sides here, you end up with the absolute value of x for the square root of x squared, or square root of x squared. Now, don't confuse that with what we call the arithmetic mean. The arithmetic mean is what is commonly known as the average. So if I'm looking for the arithmetic mean between 3 and 27, I'm just going to take 3 plus 27 and divide it by 2. So 15 is the arithmetic mean between 3 and 27. Just as a side note, what this basically, some people are asking themselves, why are we doing this and what does it mean? So if you look at 3 and 15 and 27, and you think about this as the arithmetic mean, to get from 3 to 15, you're going to be adding 12, and 15 to 27, you're adding 12 again. That's what's happening when you're doing an arithmetic mean. When you're doing a geometric mean, you're going from 3 to plus or minus 9, and then to 27. You are going from here to here, and from here to here, and you are multiplying by the same amount. Multiplying by 3 here, multiplying by 3 here. Obviously, with a negative 9, you would be multiplying by negative 3 in both cases. So that is the difference between a geometric and an arithmetic mean. All right, let's move on and let's practice some cross-multiplying. Okay, looking at some cross-multiplying problems here. Letter E, if I cross-multiply here, I'm going to get 18y is equal to 10y minus 30. Bring the y's to the same side, so it's 8y equals negative 30. And so y is just going to be equal to what? Negative 30 divided by 8, which is simplified to negative 15 divided by 4. Let's take a look at f here. It's a little bit more challenging. Cross multiply again, like this. So I get multiply the x plus 2 times the x minus 1. Just FOIL that. Equals 18. So this. So you get x squared plus x minus 2 equals 18. Hopefully you followed that. Okay. Subtract 18 from both sides. X squared plus x minus 20 equals 0. Factor it. X plus 5, x minus 4 equals 0. Hopefully you're following along okay. Zero product property, x is equal to negative 5 or positive 4. Okay, let's flip over to the backside and try a few just random problems. Okay, taking a look at the backside here, I would like to go after this one first. Find the fourth proportional to 2, 5, and 7. So if I take these a proportion, this over this is equal to this over this, and I say that this is the first position, this is the second position, third, and the fourth position. So I'm looking for the fourth proportional, so I'm looking for the x that belongs right there. So I'm going to erase these just so that you don't get confused. But that's where I'm looking for my number. And then I'm basically going to fill the blanks in. 2, 5, and then 7 goes here. So if I were looking actually for the third proportional, it would be something like this. It would be 2 is the 5, that's the first and second positions. X would go in the third position, 7 would go in the fourth position like this. Okay, but this is actually the original problem. Cross multiply, solve for x. Let's take a look at letter D here. So if I want to find the ratio of y to x, so y to x, if I said x to y like this, it would be find x divided by y. But we're looking for y over x, y to x. And then what you have to do is you have to kind of ask yourself, what's going to give you this? So if I cross multiply like this, what number has to be in this spot right here times the x to give me 9x? So I'm going to put in 9 right there. and then ask yourself, what times the y is going to give me 27y? So it's going to be 27 here. So the answer is just going to be, simplify that, 1/3 right there. If I had asked for x over y, then the answer would be flipped. It would be 3/1, like this. Let's try another one. Find the ratio of x to y here. So I'm looking for x to y. So if I cross multiply, I get 3y plus 45 equals 9x plus 45. Conveniently, the 45s would drop out. If I subtract 45 from both sides, 3y equals 9x. Now I'm in a position where I can do exactly like I did in the previous problem and ask myself, what times y is going to give me 3y? So it's going to be 3 on top, 9x. 9 is going to be on the bottom here, right? 9 and x. So again, the answer in this case is 1/3. All the answers are not 1/3. It just happened that these two in a row ended up having answers that were identical. Okay, hopefully that helps. I think I'm going to stop here and let you try some problems on your own. Okay, good luck.